Have you ever been there, staring at your screen, just completely stumped on which AI model is, actually the right one for your project?
Oh, absolutely.
There are so many options, different models, specs that look like, well, intimidating, frankly,
Yeah.
and this tangled web of licenses.
hmm
It feels like finding a needle in a digital haystack, right?
hmm
When all you want is
Yeah.
what best for what I need.
It's a super common challenge, and that's exactly why we're doing this today.
But
Welcome to a deep dive that aims to cut through all that noise. We're going to really untangle this dynamic world of open and accessible AI models. We've pulled together insights from, well, a pretty comprehensive analysis of the leading contenders.
okay, so our mission today then is to demystify what makes an AI model best. And, spoiler alert, like you hinted, it is absolutely not one size fits all.
Exactly.
We want to help you understand the current landscape for these key things: conversation, reasoning, and code generation.
That's the plan. We'll unpack the different ways people use the word open in AI. It gets confusing.
Mhm.
We'll introduce you to the key players, the ones really pushing the boundaries.
Right.
We'll evaluate how they perform on critical benchmarks and, crucially, guide you through the practical side, things like self-hosting, hardware needs, and that often tricky licensing environment.
So by the end of this, you should have a clearer roadmap, right?
Hmm.
For choosing the model that fits your project, whether you're, say, a solo developer or maybe a growing startup or even a large enterprise.
That's the goal. Let's jump in.
Okay, let's unpack this idea of best first.
Mm.
Because as you said, it's not about finding one winner, it's relative.
Mhm.
What do you mean by that exactly in the context of these AI models?
Well, what's fascinating here is that finding the best AI model isn't really about crowning some universal champion. It's entirely dependent on your specific use case.
Okay.
You're always making trade-offs, right? Balancing that raw performance with computational costs, how easy it is to access, and those licensing constraints we'll definitely get into later.
So what's best for a huge company might be totally wrong for me as a solo dev.
Precisely. It's a genuinely strategic decision for you based on your circumstances.
And it really feels like this landscape is shifting incredibly fast. I mean, we used to talk about proprietary models, OpenAI's GPT-4o, Anthropic's Claude 3.5 Sonnet as just the undisputed leaders. But you're saying that gap, it's narrowing.
It's narrowing fast, absolutely. While, yes, those elite proprietary models often still top the overall leaderboards, the actual performance gap between them and these publicly available open-weight models is shrinking at, well, an accelerated pace.
So models from places like DeepSeek AI, Meta, Alibaba, they're catching up.
They often rival or sometimes even surpass the proprietary ones in specific areas now. And what this really means for you, the listener, is that cutting-edge AI power is becoming much more accessible. You don't have to rely solely on the big closed-source providers anymore. It opens up huge possibilities for custom solutions.
And this is where it gets really interesting geopolitically, too. We're seeing this significant global shift in AI leadership. It's not just US-based companies anymore, is it?
No, definitely not.
Yeah.
The rise of these top-tier models from China-based firms like DeepSeek and Alibaba, it marks a really profound diversification in AI leadership. It genuinely challenges that long-held assumption of, U.S. dominance in the field.
How are they managing that?
Well, this shift introduces new competition, highlights the global nature of AI innovation, and their ability to train these powerful models, sometimes, like you mentioned, even on less advanced hardware because of trade restrictions. It demonstrates a pretty remarkable level of resilience and, frankly, architectural ingenuity.
That's a really powerful point. Okay, so when we talk about open in AI, it can get pretty confusing. I feel like that term is, well, thrown around a lot, sometimes more for marketing than reality. What does open really mean here?
Yeah, that raises a really important question. What is open in AI? You're absolutely right. The term open source has become something of a marketing battleground. It often gets stretched to fit commercial strategies.
So developers need to be careful.
Exactly. This ambiguity means you, as a developer, need to exercise careful due diligence. There's really a whole spectrum of openness, not just, one single definition.
Okay, so on one end of that spectrum, we've got what you'd call truly open source. What does that look like?
Right, the truly open source models, these are released under industry standard permissive licenses, think Apache 2.0.
Right.
This grants really broad permissions for use, modification, commercial distribution, minimal restrictions. It embodies that traditional spirit of the open source movement. Mistral AI's foundational models, they're a prime example of this.
So for me, using that means maximum legal safety, flexibility for commercial stuff, no hidden catches.
Pretty much, yes. That's the ideal scenario for freedom and safety.
And then there's this middle ground, which seems maybe the most common and, like you said, often contentious, permissive open weight with restrictions. Could you break that down?
Yeah, this is where it gets a bit trickier. You have companies like Meta or DeepSeek releasing the model weights, sure, but under custom licenses. And these licenses impose specific, sometimes pretty significant restrictions.
Like Meta's Llama license.
Exactly. Meta's Llama Community License is a great example. It requires companies with over 700 million monthly active users, that's a lot of users, to get a separate commercial license.
Ah,
So this implies a strategic choice for you,
right.
right? Are you aiming for that kind of mass consumer scale where this threshold becomes a real barrier? Or are your applications maybe more niche, making this license perfectly workable?
And the open source initiative isn't keen on these licenses.
Well, it's worth noting the OSI has stated that licenses like these fail their open source definition because they discriminate against certain types of users or scales of use.
Right. That makes sense. And what about the other end of the spectrum, where models are like source available but not really open?
Yeah, that category includes models where the weights are available, but they're explicitly limited to non-commercial or maybe research-focused use cases.
Okay, like which ones?
Mistral AI's most powerful models, think Mistral Large 2 or the specialized Codestrol, they fall into this group. They use licenses that let the community study and evaluate these state-of-the-art architectures, which is great.
Right.
But crucially, they protect the provider's main commercial interests by restricting how you can use them in production. No building commercial products on top.
Okay, that's a clear breakdown. So if I'm listening, thinking about all these options, why would I even consider self-hosting one of these open models instead of just, using an API from OpenAI or Anthropic? What's the actual value proposition?
That's a great question, and honestly, it comes down to several really compelling advantages. The primary one, especially if you're handling sensitive information, is definitely enhanced data security and privacy.
Right, keeping your data in-house.
Exactly. By keeping all your sensitive data, all the AI inference within your own infrastructure, you basically eliminate the risk of data leaks or, unauthorized use by some third-party provider. No sending confidential prompts out into the cloud.
That's huge for many businesses, I bet. What else?
Well, beyond security, self-hosting can lead to really significant cost savings, especially at scale. Think about applications with high token throughput.
Lots of usage.
Yeah. You simply avoid those per transaction API fees. And trust me, those can really add up when you're processing millions, maybe billions of tokens.
Okay, security, cost, anything else?
And finally, having access to the model's weights, its architecture, it gives you unparalleled transparency, and it enables deep customization. You can fine-tune the model for your specific domains, your specific tasks, in a way that's just impossible with those black box APIs.
Right, you can't really tweak GPT for it itself.
Exactly. With open weights, you have that control.
Okay, so with all these practical pluses for self-hosting, the next obvious question is, how do these open models actually perform, in the real world? Let's start with maybe the most intuitive one. Conversation. What makes a good conversational AI? It feels so subjective compared to, say, a math problem.
It absolutely is. Trying to really nail down what good conversation means is always tricky. It's not just about factual accuracy, right?
Right.
It's about being genuinely helpful, engaging, hitting those sort of subtle human notes. And to try and measure this, the AI community is increasingly turning to these human preference-based evaluation platforms, like Chatbot Arena.
Ah, yes, I've heard of Chatbot Arena. How does that actually work, and what's it telling us about these open models versus the proprietary ones?
So Chatbot Arena is essentially a crowdsourced project. Real users interact with two anonymous models side by side. They chat, then they vote for which one gave the better response.
Blind test, basically.
Yeah, exactly. A blind head-to-head competition. And this generates an ELO rating, similar to how chess players are ranked, to measure that perceived quality.
And the results. Are open models competitive?
The striking trend is just how highly placed these leading open weight models are. We're talking DeepSeek R1, Qwen 3 235B, Meta's Llama 3.1 4U05B. They've secured spots right up there in the top tiers. Often, they're becoming basically indistinguishable from their closed-source rivals for many common tasks.
Indistinguishable. So for the average person using them, the quality gap might be gone or almost gone.
Precisely. While, sure, a statistical gap might still exist on paper, the actual ELO score differences are often so small that the average user genuinely wouldn't notice a difference in everyday interactions.
Wow.
It really suggests that the main barrier to building a world-class chatbot isn't necessarily access to a top-quality model anymore. It's more about the engineering challenges, the financial challenges of actually deploying and optimizing one effectively.
That's a really interesting perspective shift. And it's also interesting how models designed primarily for reasoning, like the DeepSeek R1 you mentioned, are doing so well on general conversational leaderboards. What's that about?
Yeah, that indicates that user preferences themselves are evolving. People seem to have a growing appreciation for models that can show their work, basically. Demonstrate a clear, logical thought process, what we call chain of thought, even in just a general chat.
So showing the steps matters.
It seems so. DeepSeek R1, for instance, it's trained to actually generate that step-by-step chain of thought. It
Hmm.
doesn't just spit out an answer, it shows its reasoning, kind of like a student solving a math problem on the board.
Makes it more transparent, more trustworthy, maybe.
Exactly. More transparent, more reliable. It seems strong reasoning is becoming a really essential component of what people consider a high-quality conversational agent now.
Okay, chatbot arena sounds like a game changer for evaluation,
Yeah.
but should we be cautious at all when looking at these leaderboards? Are there like subtleties or potential biases we need to know about?
That's a crucial caution. And yes, while it's invaluable, the chatbot arena rankings can be influenced. For example, some providers might do a lot of private testing, tweaking things, and then only submit their absolute highest performing versions for the public ranking.
Ah, so it might not reflect the typical performance?
It could potentially skew perception a bit.
Yeah.
So you should definitely view it as a strong directional guide for model capabilities, absolutely, but maybe not an infallible measure of their absolute real-world performance against literally every competitor out there.
Got it. Use it as a guide, not gospel.
Exactly. And we also use complementary metrics, things like MT-Bench, which uses another LLM as a judge, that offers more scalable, consistent evaluation and often correlates well with human judgment anyway.
Okay. So for conversational AI specifically, what are the key takeaways for our listeners who might be building applications?
For your applications, the choice really boils down to balancing latency, quality, and cost.
Right.
What do you need most? For things like real-time, low-latency chatbots, you probably want smaller, efficient models. Something like Mistral Small 3 is ideal. They can often run on surprisingly modest hardware.
Okay.
But if depth and nuance in the conversation are absolutely paramount, then you'll look towards the larger, more powerful models. Think Llama 3.1 405B, DeepSeek R1, the top-tier Quen models. They offer state-of-the-art performance, genuinely competitive with the best proprietary systems out there.
All right, let's switch gears a bit from conversation to, well, pure intellect. We're talking about a model's inner mind now. Logic, mathematical reasoning. How do we even benchmark something like intelligence? That sounds hard.
It is hard. To really try and peer into a model's brain, so to speak, we use a whole suite of critical benchmarks. These test different facets of intelligence and problem solving.
Like what kind of tests?
Well, there's MMLU that evaluates general knowledge across, I think, 57 diverse subjects. Then GSM-8K, that's for multi-step reasoning using grade school math word problems. There's math, which is tougher competition-level high school math problems testing abstract reasoning, and things like Big Bench Hard, which really pushes the limits of logical inference with some very challenging tasks.
So these aren't just trivia quizzes. They test actual thinking.
Exactly. They're designed to test a model's ability to truly reason, deduce, and solve problems, not just recall facts.
And on these tough benchmarks, you're saying open models are actually what, surpassing expectations? That sounds like a big deal.
It is a big deal, and the data consistently backs it up now. The largest open-weight models are achieving scores that meet, and in some cases even surpass, top-tier proprietary systems.
Really? Give me an example.
Okay, Meta's Llama 3.1405B scores an incredible 96.8 on GSM-8K. That's actually higher than the reported score for OpenAI's GPT-4o.
Wow, okay.
And DeepSeek V2 Chat gets 53.9 on that really difficult math benchmark and 92.2 on GSM-8K. That puts it firmly in the elite tier.
So what this really means is you don't necessarily need to pay for a closed model anymore to get top-level reasoning.
That's the takeaway. Powerful, open alternatives for mathematical and logical reasoning are definitely here.
So the game has shifted. It's not just about if a model can solve these problems anymore, but maybe how efficiently and how reliably it can do it.
Exactly. That's the new frontier. The focus has moved to efficiency and reliability. And this puts a much greater emphasis on things like architectural innovations and clever training methods.
Like that chain of thought thing you mentioned earlier.
Precisely. Models like DeepSeek R1, for example, are trained using large-scale reinforcement learning. This lets them actually learn complex problem-solving strategies and generate that step-by-step chain of thought on their own.
And that leads to other cool abilities.
It results in these emergent capabilities like self-verification, where the model essentially checks its own work before giving you the answer.
Okay, that's impressive. But how do we make that kind of high-end reasoning more accessible? I mean, not everyone has a supercomputer sitting around to run these giant models.
Right, that's a key challenge. And that's where a technique called distillation comes in. It's a really important strategy for democratization.
Distillation. How does that work?
Okay, imagine you have a brilliant but maybe very large and expensive teacher model like DeepSeek R1. This teacher model can generate vast amounts of high-quality reasoning data, basically showing its work for thousands of complex problems. This data, this teaching material, is then used to fine-tune a smaller, much more efficient student model. Think of the DeepSeek R1 Distill series.
So the student learns from the teacher's example.
Exactly. These student models inherit the sophisticated reasoning patterns of their larger parent, but in a much smaller package. This democratizes access, letting you run models with high-end reasoning capabilities on much less powerful hardware. It makes advanced AI far more broadly available.
That's really clever. Okay, let's talk about something I know a lot of our listeners are keenly interested in.
Yeah.
AI as a pair programmer. How are these LLMs actually changing software development? Is it just hype?
Oh, it's definitely not just hype. LLMs are truly evolving way beyond simple code completion now. They're becoming quite sophisticated pair programmers, meaning they're capable of generating entire functions, debugging really complex issues, translating code between different languages, and even offering suggestions on software architecture.
So we're seeing different types of models emerge for this.
Yeah, it's led to roughly two main types of models in the coding space. You have the specialists and then the generalists.
Okay, specialists versus generalists.
Yeah.
Are the specialized code models always better at coding than the big general purpose models?
Often, yes, for pure coding tasks. Specialized models like, say, DeepSeek Coder V2 or Alibaba's Qwen 2.5 coder, Mistral's Codestral, they're trained on absolutely massive curated data sets of code.
So that focus helps.
It gives them a distinct advantage. The data increasingly shows that for dedicated coding applications, these specialists tend to offer a superior performance to cost ratio. It seems to be a case where data specificity can often trump just raw parameter count.
But the generalists are still good.
Oh yeah, don't count them out. Powerful generalists like Meta's Llama 3 series, they are formidable contenders. Their sheer scale and strong underlying reasoning abilities make them very versatile, especially for tasks that mix code and natural language.
Okay, let's get into the benchmarks then, the nitty-gritty. How do these models stack up when we actually test their coding skills?
Right. On those function-level generation benchmarks like Human Eval or MBPP, the specialized models really shine. DeepSeek Coder V2, for instance, achieves an exceptional 90.2% pass at 1 on Human Eval.
Meaning it gets it right on the first try over 90% of the time.
Exactly. Solves nearly all the problems correctly on the first attempt. Llama 370B also posts a very strong 81.7%. So really impressive function generation.
But coding isn't just writing single functions in isolation, right?
Good point. And the shift is increasingly towards more realistic kind of agentic tasks, things that involve editing existing code bases or maybe resolving actual GitHub issues, more complex workflows.
And how do they do there?
On a benchmark called AIDER, which simulates this kind of interaction, Qwen 2.5 Coder 32B scores a remarkable 73.7%. That puts it in direct competition with top proprietary models like GPT-4o.
Wow.
And for resolving real-world GitHub issues on a benchmark called SWBench, the big Llama 3.1 405B actually leads the open models with 81.1%. That showcases its ability to handle complex, multi-file code changes.
Any others?
DeepSeek Coder V2 also performs at the top tier on competitive programming challenges, like Live Code Bench, which simulates those real-time coding contests. So strong performance across different types of coding tasks.
Okay, beyond just generating code from scratch, there's also that fill-in-the-middle capability, right, for the real-time coding assistants in our editors.
Absolutely crucial. For practical integration into IDEs, fill-in-the-middle, or FEM, is key. This is where the model completes code based on the surrounding context, filling in the missing parts of a function or a class as you type.
That's what makes autocomplete feel smart.
Exactly. It's what makes those features feel like they understand your intent. Models like Mistral's Kotrel and Meta's CodeLlama 70B are particularly noted for their state-of-the-art FEM capabilities. They're highly effective as real-time coding assistants.
This has been a fantastic overview of the capabilities, conversation, reasoning, code. Now let's maybe zoom in a bit on the major players shaping this whole ecosystem, starting with Meta and their Llama family. What's their deal?
Yeah, Meta's Llama series is undeniably a pivotal force. Their whole philosophy seems to be about catalyzing the open weight ecosystem. They do this by releasing these powerful general-purpose models.
Like the 405B one.
Right. The 405B variant in particular offers really excellent all-around performance. It competes at the highest levels in reasoning, coding, general tasks. Plus, they benefit from a huge, very active community. That means lots of support, lots of innovation building on top of their base model.
There's that catch with their license we talked about earlier, right? The user threshold.
There is that Llama community license. It's quite permissive for most users, but it includes that significant caveat. Entities with over 700 million monthly active users need to go get a separate commercial license directly from Meta.
So fine for a startup maybe, but tricky for a potential unicorn.
That's a good way to put it. You need to consider that threshold carefully if you're aiming for massive scale. Although, a key update for Llama 3.1 and later their outputs can now be used for training other AI models. That's a big deal for developers wanting to build derivative works.
Okay, good to know. What about Mistral AI? They seem to be all about computational efficiency.
That's definitely their core identity. Mistral AI is renowned for focusing on efficiency, often using that mixture of experts or MOE architecture.
Explain MOE again, quickly.
Think of it like this. Instead of one giant brain trying to do everything, an MOE model has several smaller, specialized expert brains. And it only activates the specific experts best suited for the task at hand.
Makes it faster and cheaper to run.
Exactly. Incredibly efficient, especially for its size. And a key strategic advantage for them is their use of the standard, highly permissive Apache 2.0 license for their foundational open models. That really simplifies commercial adoption.
But not for all their models.
Right. Their most powerful model, Mistral Large 2, and some specialized ones like Codistral, they use more restrictive research or non-production licenses. So check the specific model.
Okay. Moving across the globe to DeepSeek AI, a really formidable competitor from China. What are their main strengths?
DeepSeek AI has really gained prominence for, well, two things mainly: highly cost-efficient training methods and developing specialized, truly world-class models for coding and logical reasoning. DeepSeek Coder V2 and DeepSeek R1 are arguably best-in-class open-weight models in those specific domains.
And they use clever architectures, too.
Yeah, their innovative use of things like MOE and something called multi-head latent attention results in highly efficient models that really punch above their weight class, performance-wise.
Any licensing quirks we need to be aware of with DeepSeek?
They primarily use their own custom DeepSeek license. Now, it's generally permissive for commercial use, allows derivative works, which is good, but it's not an OSI-approved standard license, so it requires careful legal review to ensure compliance. It also includes specific use-based restrictions, like against illegal activities.
Oh, okay.
And it's worth noting, some earlier versions of their models did have specific content restrictions, though the community pretty quickly developed alternative uncensored versions. But some of their other powerful models, like DeepSeek R1, are released under the standard MIT license, which is very permissive. So again, check the specific model.
Always check the license.
Okay.
Next up, Alibaba's Qin family, another really strong player from China, right?
Definitely. The Qin family is impressively diverse and powerful. They have a whole lineup from very small models right up to extremely large ones. And they have state-of-the-art capabilities, especially in coding and multilingual tasks.
Like which one for coding?
Their Qin 2.5 Coder 32B, for example, is a top contender for the best overall open-weight coding model right now. It even rivals proprietary leaders.
What about their licensing situation? Is it simpler or just as complex?
It is a bit fragmented. While many of their Qin models use the permissive Apache 2.0 license, which is great, there's a but. Their largest 72B model and also their smaller 3B model are governed by a custom Qin license. And similar to Meta's, it requires a special agreement if your service hits over 100 million monthly active users.
Another threshold to watch out for?
Exactly. It adds that layer of complexity for commercial adoption at scale. So, you guessed it, check the specific model's license carefully.
Sensing a theme here. All right, finally, let's touch on Google's Gemma family. How do they fit into this open model picture?
Gemma is basically Google's entry into the open model space. They're built using the same research and tech that's behind their big proprietary Gemini models.
And what are they known for?
They're generally known for being lightweight and efficient. They deliver really outstanding performance for their relatively small parameter counts. The Gemma 227B model, for instance, is competitive with models more than twice its size.
It's efficient and accessible.
Yeah, they're also supported by a pretty strong ecosystem, including their own gemma.cpp library. That's highly optimized for running them locally, even on consumer-grade CPUs, which makes them quite accessible for individual developers or smaller teams.
And their license, let me guess, it's custom.
You got it. Gemma models are governed by the custom Gemma terms of use. Now, commercial use and redistribution are allowed, but you have to strictly adhere to a pretty detailed prohibited use policy.
So read the fine print.
Absolutely. It's not an OSI-approved open source license, so you really need to review it carefully for compliance, just to make sure your specific use case is permitted under their terms.
Okay, so we've talked models, capabilities, the big players. Now let's get really practical. If you, the listener, are looking to actually deploy one of these, what are the nuts and bolts? Where do you find them? What tools do you actually need? And the big one, what about the hardware?
Right. This is where the rubber meets the road. So first off, GitHub. It basically serves as the central nervous system for this whole open-weight AI community. You'll find official hubs for all these model families there.
Like specific repositories?
Yep. For Meta's Llama, look for MetaLlama. Mistral AI's models, they're under Mistrali. DeepSeek's various lines, like DeepSeek V2, are under DeepSeek I. Alibaba's Qwen models are on QuenLM. And for Google's Gemma, the key repo for local inference is googlegemma.cpp. Those are your starting points for downloading and exploring.
Okay, got the models. What about the essential tooling for actually running them?
For most developers, the first stop is usually Hugging Face Transformers. It's pretty much the de facto industry standard Python library for interacting with open LLMs. It gives you a unified API, lets you load thousands of models with just like a few lines of code. Super convenient.
Nice. What else?
Then there's llama.cpp. This is a high-performance inference engine written in C++ SO. It's highly optimized for running LLMs on consumer hardware, including regular CPUs and Apple Silicon chips, especially using heavy quantization.
Quantization. We'll come back to that. What format does llama.cpp use?
It uses the GGUF file format. And the great thing is, many popular models are readily available already converted into that GGUF format, making them highly portable and easy to run locally.
Any other key tools?
Well, LangChain is another really popular open source framework. It's more for building LLM applications. It offers useful abstractions, integrations with various tools, and importantly, it supports local inference frameworks like llama.cpp, so it helps you chain things together.
Okay, now for the big one, hardware. If I actually want to self-host one of these models, what do I need? Especially when it comes to GPUs. This feels like the biggest bottleneck for most people.
It absolutely is. The single most significant barrier, 9 times out of 10, is GPU video RAM, or VRAM.
Why VRAM specifically?
Because the entire model, or at least its currently active layers for efficient processing, has to be loaded directly into that fast GPU memory.
Yeah.
And the amount of VRAM needed scales pretty much directly with the model size and the precision it uses.
Okay, so give me some numbers. Unquantized models.
Right. For unquantized models running at, say, 16-bit precision, even a relatively small 7 or 8 billion parameter model typically needs something like 16 to 20 gigabytes of VRAM.
Which is doable on a high-end consumer card, maybe.
Yeah, something like an NVIDIA RTX 3090 or 4090 could handle that, but a larger 70 billion parameter model, that needs around 140 to 160 gigabytes of VRAM.
Whoa. Okay, that's not consumer hardware.
No way. That requires multi-GPU setups using professional data center cards, think NVIDIA A100s or H100s. Those are incredibly expensive. We're talking serious budget.
Okay, that sounds incredibly expensive and pretty much out of reach for most individuals or small teams. Is there any way around needing, a small fortune in VRAM?
Yeah, this raises that crucial question. How do we make these huge, powerful models more accessible? And the answer, thankfully, is yes. It's that technique we mentioned, quantization.
Right, quantization. Explain that again. How does it help?
It's a really clever technique. It essentially compresses the model by reducing the precision of its internal numbers, its weights. Think of it kind of like saving a super high-resolution photo as a JPEG file. You lose a tiny bit of quality, maybe, but the file size shrinks dramatically.
So it reduces the memory footprint.
Drastically. It cuts down the VRAM needed, often by about 75% or even more for 4-bit quantization. And this lets you run these massive models on much less powerful hardware. The performance dip is often tiny, sometimes genuinely imperceptible for many tasks.
Okay, so put this in perspective for me. If I'm looking at my home PC setup,
Yeah.
what becomes possible with quantization?
Okay, let's take some examples. A 4-bit quantized Qwen 2 Tera.5B model that needs about 1.3 gigabytes of VRAM. Tiny, anyone can run that.
Right.
A Llama 38B model, quantized, needs around 5 gigabytes, totally achievable on most modern gaming cards.
Okay, getting bigger. What about that 70B model that needed over 140 gigabyte before?
A Llama 370B, quantized to 4-bit. It can be run with about 40 gigabytes of VRAM. Still requires a good setup, maybe two high-end consumer cards like RTX 4090s linked together, but it's a massive shift from needing a dedicated data center rig.
That's a game changer for accessibility. What about really huge models?
Even something enormous like DeepSeek V2 236B, quantized to 4-bit, it can be run on about 136 gigabytes. Still substantial, yes, requires a professional multi-GPU setup, but far, far less than its full precision requirements would demand.
So, VRAM is king, but anything else hardware-wise to keep in mind?
Absolutely. While GPU VRAM is the primary bottleneck, don't completely forget your CPU and your system RAM. You still need a reasonably modern multi-core CPU to feed the GPU efficiently. And you need sufficient system RAM. I'd say 32 GB is a bare minimum these days. 64 GB or more is recommended, especially if you end up needing to offload parts of the model to system memory when your GPU VRAM inevitably runs out.
Good tips.
Yeah.
Okay, and finally, we have to navigate the infamous licensing labyrinth again. You've touched on it for each player, but this is so critical for commercial projects. Can you just quickly recap the nuances for each major family, specifically for commercial use?
Right. This is where that careful due diligence is absolutely paramount. So, quick recap. Meta's Llama license. Commercial use permitted, but you remember that 700 million monthly active user threshold. And for Llama 3.1 and later, outputs can be used for training other AI models. That's a key positive change.
Okay.
Mistral. Mistral AI uses that mixed strategy. Foundational models often use Apache 2.0. Excellent, very safe for commercial use. But be really aware of the restrictive non-production or research-only licenses on their most advanced or specialized models like Cogestrel. Don't get caught out using the wrong one commercially.
Got it. What about DeepSeek and Alibaba's Qwen?
DeepSeek primarily uses its custom, generally permissive license, allows commercial use, allows derivative works without forcing them to be open sourced, but it does include use-based restrictions, like against illegal activities, so you must review those carefully. And remember, some specific models, like DeepSeek R1, use the standard MIT license, which is super permissive.
And Qwen.
Alibaba's Qwen is fragmented. Many models are Apache 2.0 fantastic for commercial use, but their largest 72B and the smaller 3B models use their custom Qwen license with that 100 million MAU threshold. So again, always check the license for the specific Qwen model you want to use.
Always check. And Google's Gemma.
Gemma models fall under their custom Gemma terms of use. Commercial use and redistribution are allowed, which is good, but you absolutely must adhere to their detailed prohibited use policy. It's not an OSI-approved license, so you really need to review that policy carefully to ensure your specific commercial application fits within their terms.
The bottom line is,
Read the license. This is just a guide, definitely not legal advice. Always review the full license yourself before committing to a model for any serious project, especially commercial ones.
absolutely critical advice. Okay, so we have covered a ton of ground here. Wow.
Yeah.
From understanding what open even means to evaluating models for conversation, reasoning, code, and then diving deep into the practicalities of hardware, tooling, licensing. What's the sort of overall takeaway from this whole deep dive?
I think the core message is really clear. The best model is highly, highly use case specific. There's no single answer. But the big news is that open weight models are rapidly reaching parity with proprietary ones. And in some specialized domains, they're even surpassing them.
Which is a huge opportunity.
It's a massive opportunity for innovation, absolutely. However, deploying them successfully means navigating that complex interplay of hardware availability, especially VRAM, getting the right software tooling set up, and carefully working through that fragmented, sometimes quite restrictive licensing environment. It's not always straightforward.
Okay, so for you, the listener, depending on who you are and what you need, maybe we can offer some tailored strategic recommendations based on everything we've discussed. Let's say you're a solo developer, maybe a researcher, perhaps a bit budget constrained. What should you look at?
Right, for that persona. For conversation, a quantized Llama 3.8b instruct, or maybe Mistral 7b instruct, run via llama.cpp, offers an excellent balance, great quality, runs well on a single consumer GPU.
Okay. Reasoning.
For reasoning, that DeepSeek R1 Distill Quinn 32B model we talked about is a real standout. It gives you genuinely elite reasoning capabilities, but in a much smaller, more manageable package.
And for coding on a budget.
For coding, look at Qn 2.5 Coder 7B or maybe the 14B version, or a quantized version of DeepSeek Coder V2 Lite. These are powerful options specifically designed for systems with limited VRAM.
Okay, good options there. Now, what about maybe a startup or a small to medium enterprise? You're building a commercial product now. What makes sense?
All right, for the startup SME building commercially, for general conversation and tasks, Llama 3.1 7UB is a top-tier generalist. It's suitable as long as your service stays below that 700 million MAU threshold.
But if you're worried about hitting that scale, or just want maximum legal safety?
Then Mistral's Apache 2.0 models are probably the most prudent choice, something like Mixtral 8x22b, no usage-based scaling concerns there. For pure reasoning, DeepSeek R1 is a leading model, and it's released under the standard MIT license, making it a very safe and powerful commercial option.
And for coding tools built by a startup.
Qwen 2.5 Coder 32B is the clear recommendation there. It rivals proprietary leaders like GPT-4o on coding benchmarks, and it's Apache 2.0 licensed, ideal for building commercial developer tools.
Perfect. And finally, let's think big. For the enterprise or maybe a large-scale deployment where performance is absolutely paramount, budget less so. What are the top choices?
Okay, for the enterprise scale, performance first scenario. For an overall generalist model, Llama 3.1 4SA5B is currently the most powerful and capable open-weight generalist available. It leads on tough benchmarks like SW Bench for code editing.
Top of the line for reasoning.
For reasoning, DeepSeek V3 or the original DeepSeek R1 represent the absolute pinnacle of open-weight capabilities right now. They're suitable for really complex analytical tasks, financial modeling, where accuracy is just king.
And for coding at the enterprise level?
It depends slightly. If you need pure code generation performance, a fine-tuned DeepSeek Coder V2 likely offers unparalleled results on those specific benchmarks. But for more agentic code editing tasks that require understanding broader context, Qwen 2.5 Coder 32B remains a top choice, even at this scale, due to its strong performance and permissive license.
Wow, what an exciting journey we've just taken. From, the nuances of open all the way to specific model recommendations and the practical stuff like VRAM and licenses. It really does shift how you think about what's possible now, doesn't it?
It really does. The whole trajectory of open and accessible AI just points toward continued rapid progress. We can definitely anticipate even greater specialization in the future, more models trained specifically for domains like science, law, finance.
Tailor-made AI.
Exactly. And architectural innovations will keep driving efficiency, allowing more powerful models to run on less hardware. That pushes the boundaries of what's feasible for everyone, not just the giants.
It's an exciting time.
It is. And maybe, finally, consider this thought. As these lines continue to blur between what we call open and proprietary, what responsibility falls on us, on the community, to really advocate for truly transparent and genuinely permissive licenses to ensure we have a healthier, more collaborative ecosystem for everyone going forward?
That is a really powerful thought to leave you all with. We definitely encourage you to explore these models, experiment with the tools we mentioned today, and continue your own deep dive into this incredibly fast-moving landscape.
This is Lincoln McCurry. Please like and follow me. Thanks for watching.